Okay, thank you very much for joining this presentation of the Paceco hybrid diesel genset, which is an ecological and profitable RTG retrofit hybridization solution. First, I would like to explain the background and make an executive summary of what this product is. First, Paceco decided to launch a project to develop a specific diesel genset, hybrid diesel genset project for RTG retrofit by the end of December 2013. We were ready to assemble the prototype by March 2015 and ready for test by May of 2015. Parallelly, C-Terminals project was launching all the prototypes development you will see this afternoon along 2014 and 2015, and the prototype test phase was scheduled for the third quarter of 2015. The coincidence in time and the need of both projects to show how hybridization technologies could be applied to improve the terminal energetic efficiency made us the possibility to make a joint collaboration and to provide the results of our test to the C-Terminals project and participate today in the demo day. So thank you very much for C-Terminals project and Valencia Port Authority. Hybridization technology is an alternative to RTG electrification. No infrastructure is required, no impacts in operations. A small investment is required compared to the electrification of a container terminal. The Paceco Group is leader on hybrid RTGs. More than 100 RTGs in operation. We are the biggest group in the world producing port machinery in terms of hybrid machines. And third, it is a specific DG set for retrofit, makes it possible to turn any RTG into a hybrid RTG, existing conventional RTG into a hybrid RTG, cuts dramatically running costs, reduces CO2 and NOx emissions, and is a small investment with a short payback and a high profitability. So this is the genset, and now through a video we will see how it works, how it's designed, and so 3 minutes description. We invite you to take a walk through with us to discover the main arrangement and design features of the Paceco hybrid diesel genset demonstrator.
The HDG enclosure is waterproof, heat and sound insulated with 2 independent sections, one housing the engine, the alternator, and the HDG PLC control, the other housing the storage bank and the power electronics. The enclosure doors and removable panels arrangement guarantees accessibility to all HDG components, easing service and cleaning. The 1,500-liter fuel tank is integrated into the HDG bed frame. The model demonstrated has an enclosure and bed frame designed to be installed onto an RTG sill beam, but a hanging version is available as well. The prime mover is a highly efficient, electronically governed 7-liter displacement Stage 3A diesel engine, coupled to a heavy-duty alternator with a specific AVR designed for multi-speed operation. This combination allows different voltage and frequency settings to match any RTG. The full management of the HDG runs in a safety PLC that can be customized to interface easily with existing RTG control through IOs, Profibus or Profinet. The whole plant is monitorized by an onboard CMS system that provides HDG operating status, fault finding, component condition, and allows for customizing parameters and commissioning, with different password levels according to different user profiles. A heavy-duty DC-DC converter manages the energy flow from and to the storage bank, providing the RTG with the required amount of power at all times. Each supercap is built in with a monitoring and safety module, providing the HDG CMS with full information on each one's status. Switching to a lithium-ion battery storage bank can be done at any time. One important feature of the HDG concept is that it can be easily customized to replace the original genset of any RTG, regardless of its manufacturer. This is achieved through modular solutions allowing multiple choices and sizings to match mechanically, electronically, and output-wise any RTG design. Additionally, different options are available for hybrid power electronic sizing, the storage bank, and the domestic loads AC-AC drive, as well as mechanical suspension.
The Paceco hybrid genset makes it possible to turn any RTG into a hybrid RTG with proven technology for which Paceco Group is leader. It's a customizable design that matches any RTG. A small investment with short payback and high profitability. Okay, I'm back. So let's go then to see why hybridizing is interesting in a machine like this one. The typical power profile of an RTG looks like a little bit like this. Very high and short power peaks. Impossibility of making load regeneration when we are lowering the load. Long idling periods. All this makes a very small average load on the diesel engine, but because of the design and because the solution, we have to cover the peak load by a conventional diesel sizing, which with a big size. The gap between the power peak and the average load actually required by the machine is extremely big. Why hybridize? No? What is the basic idea? What if we could use a smaller diesel engine to cover a power closer to the average? Why if we could cover this demand peaks with a secondary power source? What if we could store the pump back energy, which otherwise is burned in some resistors in there, on the crane for later use? This is what a hybrid RTG does, and this is what the Paceco HDG lets any RTG to do. If you put this to replace this over there, your machine becomes hybrid. What is the new paradigm? What is the new situation? Instead of having this big size diesel covering the maximum peak, if we have a downsized diesel engine that we manage electronically to provide the power according to profiles a little bit uncoupled from the actual power demand on the machine, and we provide the deficit of energy this diesel engine cannot manage with some energy from the storage bank in the machine, then we recover the energy which otherwise is burnt in the resistors. This is the new situation, the new paradigm on which the RTG hybrid works. How do we hybridize? The typical one-line diagram of an RTG crane looks like this. We have a diesel engine, we have an alternator. Then hybridizing, install this on the machine would mean to put an engine which is smaller, to provide some auxiliary system to feed the domestic loads, and this is the most important, the energy storage system, which is based in our case in ultra caps, managed electronically to provide this deficit of energy that the engine cannot supply, and then provide the capacity of recovering energy during the lowering processes. And then we are going to make a demonstration of how the machine works. My heart rate is going to rise, it's already rising, so we are switching on. We cross fingers, let's see if everything works well. Now we are initializing the machine. This takes about 50 seconds, so patience please. If everything goes well, we should be ready very quickly. We are ramping up. Suddenly we have light, and my colleague Victor, which is piloting, is going to lift and see now the diesel engine energy flow, the battery's energy flow have let the machine go up with a smaller use of energy than normally. Now we are recovering energy and filling this energy back to the resistors. We go up again, so both sources of energy are putting power to feed the machine, And now we are going to lift a 39-ton container if everything goes well, so as normal. So now we are recovering energy. Vamos, de tiempo? Okay. And now we go up. You will see both systems, the diesel and the hybrid, delivering the whole power. Look, the power about 400 kilowatts. Only 200 kilowatts are fed by diesel engine. The other 200 are coming from the batteries. So we are saving at the moment about 50% of the energy. And then we are traveling. The system is recharging a little bit the batteries, and now we are lowering and recovering all this energy that otherwise will be spoiled back in our capacitor's battery rack. Okay, I'm relaxing, everything is going well. So, okay, good. Muy bien, Víctor. Okay, so we are going to shut up, otherwise the noise is big. Vale. Pues estamos. Results of hybridation. The real-life test made here, simulating walking cycles and so on, show basically that the consumption figures got by this family of machines fed with their original genset are the yellow bars, and the blue ones are the ones with the hybrid generator. Basically, on the basics, any scenario shows that at least a 60-70% full saving compared to the original design. In a typical 15 moves per hour operation, we have about 14 liters hour full saving. In a more demanding cycle of 25 moves per hour, we would have at around 18 liters per hour saving. In euros, 50 to 65,000 euros per RTG per year at a rate of about 5,000 hours operating per year. Investment analysis. To study deeply the investment, the monies of all this, we have done a business tool study case which evaluates the diesel engine, the diesel cost, which evaluates the profiles of working hours year by year of the machinery, that analyzes the current operating running cost of the machine with the original genset, as well as with the retrofitted HDG. Then, as an example, in a typical, say, middle 90s or early 2000 machine with a 20 liters per hour consumption and running at 5,000 operating hours per year, we would have, looking to the investment at 15 years, an RERR of 60%, full saving of about 890,000 liters per year, total, cost savings of 800,000 euros per machine, saving of emissions 320 tons. Conclusions and roadmap. Hybridize an RTG fleet on existing RTGs, not new RTGs, existing RTGs in terminal is a profitable investment. The better, the higher the average consumption is, the better, the higher the working hours are, the better, the newer, the sooner I make the hybridation. Any diesel RTG should be a hybrid RTG. There's no meaning to buy nowadays conventional diesel RTGs. All of them should be hybrid. And against electrification, hybridation is a financial champion. We don't need huge amounts of money to perform the hybridation, and the figures on ROI, RER or net present value are amazing. Great investment for the terminal, but for the terminal managers is completely transparent. Any affection on the operations. For the financial managers, the monies, the results of the financial study are amazing. For asset and maintenance manager, the HDG gives a second life to the machine. The source of major problems on an RTG crane is modified and is applied with the newest technology. For RTG drivers again, there's no affection. The hybridation is completely transferred for them. For terminal managers, this goes direct to their KPIs, and for all of us, is a friendly ecological solution that reduces CO2 and NOx footprint. Roadmap to convert any RTG into a hybrid RTG. After running initial business case, we can customize, modify slightly the software to tune up the HTG against the RTG to be modified, the family to be modified. We make on-site test with a demonstrator. We make consumption test, real-life test, and finally, we run the final business case to make the decision for retrofit. This means that our customers can take the decision to go hybrid without any risk. The end. We would like to thank very much Fundación Valenciaport and Sea Terminal projects for having given us the chance to validate on real-life test the solution and to be here today with all of you. To IMOINSA, which is the partner that has integrated all the technology developed by Paceco in this wonderful, to my opinion, genset. And finally, to Noatum, that inspired somehow the concept and has supported the project from the very beginning. And finally, to my team, my colleagues of the Innovation and Project Department team, that are some kind of wizards able to convert needs from our customers to wonderful solutions. Thank you very much.